circular motion. So far we have dealt with very basic ideas about centripetal circular motion, but today we are moving on to a very important concept, and that is known as centripetal force. Before I discuss centripetal force, I need to ask you a question: why we study circular motion? As a student of physics, we must ask ourselves why studying circular motion is such an important topic. The answer partly to this question is the variety of forces that involve in the circular motion and the variety of systems that we need to understand if we want to know the universe of which we are a part. As we'll see, centripetal force is not any new type of force. It is actually any force which may be a tension in the string, it may be a gravitational force in nature, it may be a magnetic force, it may be friction, it may be electrostatic force of attraction between charged particles, which plays the role of centripetal force, which simply is a force which is responsible for keeping an object in circular motion. The role of centripetal force is to change the direction of an object. In the absence of centripetal force, naturally an object will move in a straight line. For example, if an object is moving in this manner, going straight, and suddenly a force acts on it and turns it into a circular path, and then it moves on along the straight path again, for this part of this motion, centripetal force has acted on it, which means this is the circle in which this object has moved, and this will be the radius of it. The force which has acted must be towards the direction of the center of this circle. So any force which is acting towards the center of the circle and which is essential in order to make an object move in a circular path is known as centripetal force. So if I define it, it is the force needed or required to keep an object moving in a circle. The question is, which force or forces can play the role of centripetal force? It's a long list. In fact, all the forces that we have ever studied so far, that we have ever known, are capable of playing the role of centripetal force. For example, tension in a string. When an object is tied to one end of a string and then it is whirled in a horizontal circle in this way, and it is moving with a constant speed v, the tangential speed, this is the tension in the string which is responsible for keeping this circular motion. In the absence of this tension, this stone of mass m will simply move along the straight path. So there will be no circular motion possible if there is no tension provided by the string. So if I denote tension by T, which is the centripetal force in this case, this must be equal to m v square over r. You will remember this expression. This is the expression which is always used for calculating the centripetal force. Let's say I don't have any idea what is the tension in the string, but I know that a stone of mass 0.50 kg is moving at a speed of 3 meter per second on a string of length 0.75 meters. Calculate the tension. So if I need to know what is the centripetal force necessary in order to make this happen, so a stone of this mass moves at this speed in a circle of this radius, I will be using this expression mv square over r. So naturally, this will be 0.50 multiplied by 3 squared divided by 0.75. So this will be my answer in newtons. So tension is playing a role of centripetal force. If I know the mass of the stone, if I know the speed with which it is moving, and if I know the length of the string, in other words, the radius of the orbit, I can calculate the centripetal force required for it. Which simply means that if I move this object at larger speed, I whirl it even faster with the same mass in the same radius, larger force will be required to keep this in the motion. But maybe the string is not very strong, it's not very durable, maybe it snaps. So with increasing value of V, maybe this string is simply unable to withstand this tension and it snaps. So centripetal force is the required amount of tension, and if the tension goes on increasing, maybe this string is unable to provide that tension and we have to provide with a more durable, with a thicker, more durable string. So tension is not necessarily present by all amount, whatever the value of V. If we go on increasing tension, maybe we need to replace with the new string. Another example of the force which plays the role of centripetal force is friction. We all know that at times cars move on level roads. If we view it from behind, for example, this is the car, we are viewing it from behind, they are moving away from us, but they are moving on a level road which is taking a turn in this manner. So it is something like a very large circle in which this car is moving. Maybe this is 1 kilometer radius in which this car is moving, because usually it's a large radius, a large circle in which the cars move while taking the turns on the roads. What is the force in this case which is responsible for keeping the car on the road and it doesn't skid away? That is the friction between the tires and the road. So if friction is the centripetal force, and I need to know how much friction is necessary in this case so the car remains on the road without skidding, again I will be using mv square over r. Let's say in this case, mass of the car is 1000 kilogram. And let's say the car is moving at a speed of 20 meter per second, which is roughly 80 kilometer per hour. And the radius is 1000 meter, which I have written as 1 kilometer. If I use these values, I can easily calculate the necessary friction which will be responsible for keeping this car on the road. In the absence of this friction, this car will simply move off the road. It will not be able to remain on the road because the friction is simply not enough. This is the common observation that on a muddy road, on a wet road, we slow down. If we are taking the turn, we slow ourselves down because we know that the friction is not necessarily enough now. So it is very riskful if we continue moving. If we continue moving with the same speed, so we slow down usually. So if I use these values here, let's say mass is 1000 and speed is 20 meter per second and radius is 1000. So if I simplify, you can easily see this is 400 Newton force which is necessary to hold this car on the road. So at least on the level road, it is the friction alone which is responsible to keep this circular motion. But sometimes cars are not moving on level roads, they are moving on the banked roads. By banked roads, I mean roads which are banked this manner, they make certain angle to the horizontal and the cars are moving on these roads in this manner. Once again, you are viewing this car from behind. They are moving away from you at certain speed v. And this time, the force which is moving this in the circular motion is predominantly the surface reaction force. If this surface reaction force is making an angle, if this is theta here, this must be the angle theta here. So if I resolve this R into components, one along the vertical, the other along horizontal, this R sine theta will be the force towards the I go back to this case where friction was responsible for keeping the object in circular motion. There was no angle theta involved here because the force was entirely towards the center. There were no components required because friction was simply acting towards the center. But in this case, the normal reaction force is normal to the road, which is at an angle theta to the horizontal. So R has two components now. This normal reaction has one component R cos theta, which is vertical, which is not of our interest, but the other component, which is towards the center of the circle, is R sine theta. So R sine theta here is the force which is playing the role of centripetal force. If I want to calculate this force now, again I need to know what is the mass of the car, what is the speed at which it need to move, and what is the radius of the circle in which it should be moving. Another example in which we have a force acting at an angle is that of we talked about a pendulum bob which is initially displaced from its equilibrium position here, and then it is pushed away from us. When it is pushed away from us, it starts moving in a circle like this. What is the centripetal force acting on this bob? Naturally, the tension in this string is directed towards the support from this bob. And in this case, if I know this is the angle theta that it makes with the vertical, because usually it is this angle that we consider when we displace the bob from its mean position, this t can be resolved into two components again. One is this, the other is this. Once again, this t is t cos theta and this is t sine theta. Which of these two components is playing the role of centripetal force? The answer, I hope you guess, is t sine theta, and this is equal to mv square over r. So whatever the force, whatever its nature, whatever its component acting towards the center, we always equate it to mv square over r in order to work it out. Another interesting example. Suppose a charged particle, let's say it's a proton. A proton is entering a region. Let me make a figure of it instead of writing. This is the downward magnetic field, and a proton enters this region. A proton is coming in this manner. It enters this region, and as soon as it enters here, it starts moving in a circle like this. Suppose this is the path it follows. This is a stream of protons. This is the radius. Let's say this is 10 centimeter radius, and the speed with which it was initially moving, we assume some value, let's say 2 into 10 raised to power 6 meter per second. What is the force which is magnetic force in this case? Magnetic force, a magnetic force needed to move this particle into circular motion is simply mv square over r. I know the mass of the proton. This is 1.66 into 10 raised to power minus 27 kilogram. I know the speed with which it is moving, 2 into 10 raised to power 6. I know the radius in which it is moving, 10 into 10 raised to power minus 2 in meters. So if I simplify this all, I get my answer in newtons. This is the force which is not much because it is a proton, so it will be probably of the order of 10 raised to power minus 14 or minus 15 if you work it out correctly. Similarly, instead of a charged particle such as proton, it may be a stream of alpha particle entering a magnetic field. The worksheet that I have given you, I have changed the protons, replaced the protons by alpha particles. So you can attempt that question easily now because this is simply the formula that we'll be applying there. Another question about centripetal force, and this is the last one. Then we'll talk about centripetal acceleration. Centripetal force acting on the Earth, the planet Earth, by the sun. This is sun, and this is the planet Earth. The distance between them is 150 million kilometer. So this is the radius of the orbit in which Earth goes around the sun, 150 kilometer. If mass of the Earth is known, we know mass of Earth is 6 into 10 raised to power 24 kilograms. And we know the angular speed with which this Earth is going around the sun. And this is 2 into 10 raised to power minus 7 radian per second. What is the force that sun is exerting on the Earth in order to make it move in the circular path? That force, which is obviously the gravitational pull of the sun on the Earth, that we'll study in detail in the next chapter, that is provided by mv square over r. But this time we'll change slightly this expression because instead of v given, we know omega. So we'll use v is equal to r omega whole squared divided by r. So when we simplify, it becomes m r omega square. So this time the centripetal force is calculated using m r omega square. If we know the mass of the Earth, which is 6 into 10 raised to power 24, if we know the radius of the orbit in which Earth is moving, which is 150 million kilometer, and if we know the angular speed of the Earth, which is 2 into 10 raised to power minus 7 radian per second, we'll substitute all these values in this formula, and we know what exactly is the gravitational pull that the sun is exerting on the Earth and playing the role of centripetal force. So this concludes our discussion of what centripetal force is. Let's talk about what is centripetal acceleration. Centripetal acceleration. We all know that circular motion is an accelerated motion. Although the object is moving at a constant speed, but due to continuously varying direction of the object, it is said to be an accelerated motion, and the direction of this acceleration is always along the force that is acting towards the center. So centripetal acceleration is the acceleration directed towards the center. It is the acceleration directed towards the center is known as the centripetal acceleration. When an object moves along a circular path, and this is always calculated using V square over R. If you remember, the force was mv square over R, and using the famous Newton equation F is equal to ma, the acceleration is v square over R. I mean, if F is equal to mv square over R, this is equal to ma. So this is the centripetal acceleration, v square over R. And if I express it in terms of omega, this is R omega square. Because if I replace V by R omega, this will become R square omega square over R. So it reduces to R omega square. Sometimes they ask you to calculate the centripetal acceleration instead of centripetal force. So no need to worry about the mass then. You simply use the values of speeds, either the tangential speed or the angular speed with the value of the radius of the orbit, and you can easily work out the value of the centripetal acceleration. So this is all from my side for today. We can start the question answer session now after 5 minutes.